Okay, I think we're ready to start here from Vienna. Bob, do you want to go ahead?
Yes, good. I guess morning in Vienna, very early in the morning for me. Um, so this is a 6-man working group. Next slide. This is Note Well, which you should all know by now. We'll have a test at the end, but basic description of the IETF process, how it relates to meetings. Um, we're using Meet Echo in a slightly new way this time because this is a hybrid meeting. If you're in the room, use the light version to join the queue. Don't use audio and video if you're in the room. If you happen to be, there's a light version, which since this is Tuesday, you should all know about. Um, and, likewise, only turn on your audio and video if you're speaking or presenting. And we recommend headsets. Next slide. Um, the usual agenda for the IETF. Next slide. We have the Jabber room being run out of Meet Echo. You can also access it with Zulip, which I have running in the background somewhere. So where the minutes are. Many thanks to Shu Ping for taking minutes. If there's someone else who also
I,
wants.
I think Pascal Tubert also volunteered to help out with the minutes, so we have
Oh,
two.
excellent. That's great. Thank you, Pascal. And I'm getting a little echo. Can you hear me okay?
We can hear you very well.
Okay, good. And here's the link to the presentations. Next slide. So we have two agenda slides doing the introduction and agenda bashing. We have 4 working group documents to discuss. Um, as you note here, Tom Herbert submitted slides, but he had some other family obligations that kept him from being able to present. So we will have a little extra time for the agenda, which is good because it was already very tight. But he would appreciate feedback on his draft on the list. But his slides will be in the presentation. We have 2 active internet drafts: the segment identifiers, the Suresh segment identifiers, and SRV6 that was discussed quite a lot um, last time. Will be presented, and then Ted will be talking about source address selection. Next slide. And then we have 5 short presentations on new drafts that haven't had much discussion, or it's unclear what the level of working group support is that we hope to get to. And I think we should have time this time for a brief talk on each of those. These are intended to be introductions to this work, not to have a big discussion. Next slide.
So hang on a second, Bob. We lost SlideShare here in the room for some reason.
Oh, that's odd. I can see them fine.
You think we lost the projector, Michael? Yes, that one.
In this room, this room.
Meet Echo folks said they're coming
That,
in the chat room.
yeah. So there's this HDMI splitter that drives that screen and that projector.
Right.
Here's the splitter.
Yeah, yeah. That's the. I can have a look.
Okay.
So there was a NAT in the HDMI path that lost state. Yeah. Yeah, yeah, that's a common problem. Okay. So sorry about that. We now got technical help from Miteco, and we're back running in the room.
Good.
So,
All right, next slide. So, Oli, I'll hand it off to you.
thank you. So document status. So since the last meeting, we have published one RFC 9131 on gratuitous neighbor discovery. We have nothing in the RFC editor queue. We have 3 documents submitted to the ISG. We have the OAM document in segment routing, which has 1 discuss. We have the alternate marking method, which is it down to 1 discuss now? Otherwise, it's 2. And we have the minimum path empty hop by hop option document. Eric, do you want to say a little bit about these, the status of these in the ISG?
I just issued the ballot for MTU option and requested putting on a telechat. So that might be on the first telechat in April or the second telechat in April. The alternate marking document is waiting, I think, on the IPPM stuff to be revved to a proposed standard so that it can be a normative dependency. Martin Duke is AD sponsoring that work, I think, at the moment. And then the SRv6 OAM, I need to refresh my brain on the state of that. I think
Safar,
we
do you
were
want
waiting
to
on.
say something about the status of that, or if you're here? Yes, Safar, go ahead.
Can you hear me? Yeah.
We can hear
So,
you now.
yeah, good. So we have a discuss from Ben. We have addressed the comments from Ben and sent an email to him as well. So the comments has been addressed in revision 13. However, Ben hadn't had a chance to clearly discuss. That's the only discuss pending.
Yeah, that's right. Ben is working to clear all of his document queue before tomorrow evening handover. So hopefully he'll get to it. If not,
Great.
I'll follow up and ask the incoming SecAD if they want to pick up his comments and complete the review.
Yeah, excellent. So
Thank you.
it seems like these are finally progressing. They've been at the ISG for about 300 days, I think. So, but at least there's no action from the working group. Thank you. And we have nothing awaiting write-up or in adoption calls. We have 4 relatively new working group documents. We have the zone identifiers document that just passed adoption call that Brian is going to video talk about later. We have the limits on sending and processing IP6 extension headers. There is a presentation in the proceedings, but Tom can't present on that. It's the VTN identifier in IP6, which we have talked about, and it's the hop-by-hop options processing procedures, which Gori will talk about just now. Any comments on that before we leave the floor to Gori? It's a very small pink box.
Yo! I don't know whether I can do that.
Okay, so this is the IPv6 hop by options processing procedures, and it's Bob and I who are the document editors. This is the first working group version of this document, but now we're at 0.1 because we did some tweaking after we started the process. So we'll describe to you where we got and hopefully interest you in helping us to get to the final destination. So next. Well, the first line I think we can generally agree on. Hop by hop options are not working in the internet. There may be some disagreement about whether they should, ought, must work, but that's kind of where we're starting from. They're not working. It's very common for routers to drop hop by hop option headers. Where they do it and which ones do it is kind of an interesting measurement problem, and probably we should delve into that. We will hopefully see more data. 8200 said that it would document the current practice. So when we moved to full standard, we changed the wording to document what we thought was the current practice, but probably not really where we should be in the future. So this is all about what happens next. And it was adopted. Well, we know that. Next slide, please. Changes from the individual draft. Well, we listened to the working group. We didn't necessarily find the answers to the questions that were raised, but where we found answers, we changed the text. Right, so there is a kind of elephant in the room which could sink us. It's all right, I carry on talking while you figure out what to do. So we just, Bob, we just lost the video to the projector, but I think we can carry on talking. One of the big questions we have to figure out is what language do we use to talk about this thing that we called FastPath, which was a nice, simple option between doing something in an accelerated hardware or software fashion versus doing a big full parse of the packet headers. Life's not quite so simple now as it used to be, and we're going to get stuck on words if we don't watch out. So Bob and I would like to take this as a separate thing of just believe at the moment that we can actually find those words in the future to describe these two aspects of a router, the things that can be done very fast and the things that can be done with a little bit more processing and parsing and checking. And with lots of editorial changes. Well, we'll go for the next slide. As you can see, we've enabled the issue tracker and we've given this helpful URL, which you can now go to see all the issues. Okay, so it's all right, I can talk to this if we get soon, it would be good.
So people can either go into the Mitico and act as they are remote and they can see the slides, or you can just look at the PDFs. So here's our technical support. Here's technical support. Okay. So the real takeaway from this slide is when we did the adoption call, lots of people responded. Thank you ever so much. Lots of people responded with a, yeah, let's do this, but, and they had some sort of issue. And we thought as an experiment, what we would do is try and capture as many of those as we could actually work out from parsing the thread and put them in the issue tracker straight away. So not only have we done an adoption to say, hey, we'll do this work, also we captured a whole range of different thoughts about how that work should be done. It's kind of odd to go to the first working.
Sorry, Corey, could you hold for a second?
Yes.
We're getting Brian Carpenter's video being played somewhere.
Yeah, are you not playing it yourself, you think?
I hope not. Apparently I was. Sorry about that. I don't know what happened.
Well, Bob, we've got slides here, so your parallel universe, I think we'll carry on. Okay, so this is the URL. I mean, it's the working group's URL, so you can find it. But please go there because we'll use it. And we will pass the mail thread and try and add issues to this. If you feel inspired, you can go and add an issue yourself. And surely please comment on the issues as we try and respond to them in the tracker so we can assemble this mass of slightly conflicting responses to get something coherent at the end of the process. So, are we ready to go? Right. Now we look at the issues. Hopefully we'll have fewer of these as we do each presentation to 6-man. These are the short things. Most of these, we hope, are just fixed. Does the working group have ASIC experience with extension headers? We think that's someone else's drafts problem. We're going to cite 7827. We've changed the text on size of extension headers, arguing that maybe different sizes are okay. Maybe this isn't a great saving to people implementing to say that you just have one size. I mean, all of this can be undone if you prefer something different with good arguments. Better to encode hop-by-hop processing in the destination address is an interesting proposal, but I think it changes the IPv6 architecture. So for the moment, we've cast that one out. And we changed the spelling mistake, which was fun because we didn't see it. Next slide, please. Right, now here's one with more substance. Why do leading edge line speed routers want to ignore the hop-by-hop extension headers? What is it they will get as benefits if they don't ignore them? I think if we can't answer this question properly by the end of the document, nobody will bother reading the document. So this is actually fundamental and not obvious. Yes?
What would they get by not
Mike,
Well, either way, right? Yeah, right. But seriously, both ways we need to put that argument through and figure out what it is that is the right thing to do. You know, is there benefits for not ignoring it? No, I'm not going there. And the meaning of should and musts needs full care in working it out, because it could be one of these places where should and must seems like simple words, but probably need to be really explained in context here. So that wasn't very helpful, but it was just saying issue 2 is the one where really it would be good to get a little bit more text and thoughts. Do you want to say any more, Bob?
No, that's fine.
Good. Then next slide, please. Issue 4 notes that nodes do not need to process the payload. Yeah. Hop-by-hop actions considered payloads. This refers to IRC 9098. And maybe we need some text around forwarding nodes that loop into what people often call the transport header, the offset it can be. There are things related here to the work by Tom Herbert, so we probably have to link with that, but it does have an impact on whether the hop-by-hop option is finally passed. So, action needed here. Next one. This is the rat hole. What do we call the way in which routers sometimes do things better with some types of packets and headers than other types of packets and headers, which can be actually causing them more pain? Right, so I invented with Bob the idea of full forwarding rate. Define full how you like. Forwarding is certainly what's happening, and rate is the thing that's affected. And the idea being simply to try and move away from the fast path, slow path, which has many connotations. If there's better language, we'd love to move to the better language. If this works, then we'd love help to try and make it perfect. So if anyone wants to kind of chime in and say something like full forwarding rate is horrible and I think it should be this, go ahead. It'd be more fun to have other people talking rather than just me. We got a question, did RCH200 make a difference to deploy practice?
so Tolis, did you have a question on the previous slide?
Oh, Thomas, yeah.
Oh yeah, just the comment, right?
Yes.
I think if we define it to be, the same throughput as without the option header, right? And then the question is that reasonable to expect, right? So I think the minimum functionality that we need to look into is to be able to do all the crappy things that a platform may do in looking into layer 4 information to skip through the chain of extension headers, right? And that's the big question, if we can expect that to be without performance penalty. So maybe So in other cases like control plane, we did questionnaires, right? So
Yeah.
we just did questionnaires in multicast. So maybe, starting to put together a questionnaire for relevant things that we want to learn to help improve this might be, an option to look into.
Okay, so a questionnaire might help.
So that was Tolle Sekert. Thank you. I'll call people's names to help the note takers. So Curati Kumbala, please
Hi.
go ahead.
So full forwarding rate is probably not a good term. There are times when you move the packet through the forwarding hardware and you get half forwarding rate, or you might give up some of the forwarding to do this. The big thing is the previous slide where it's like, why would we even bother? And if you said must, and we think in our ASICs we can't afford it, we might just ignore the must. So the question is, what's the value of processing hop by hop? What are the kind of options you're putting there, and how would it help? If it's worth processing, it doesn't have to be full forwarding rate. So I think fast path and slow path is probably better, because for me, slow path is like really slow, and fast path is pretty fast, but it may not be full forwarding rate.
Excellent.
Does that make sense?
It makes sense, but then I'm sure other people will argue slightly differently, and this is just wording that we have to get right, because there's some semantics behind it. We have to just capture that.
Yeah.
Yeah, okay, I hear what you're saying.
Okay, cool. Thank you.
I will carefully think on those words.
Ben Madison work on mine. Sorry, my app doesn't want to work. So I suppose my feedback here would be roughly the same as Kariti's. For me, what's important is not necessarily the forwarding rate, but the determinism of the performance. As soon as you start punting stuff, you don't know in advance what the various bytes are going to do to your CPU.
Right, and that was the slow path thing. Was kind of like, I'm going to go through a decision tree about how to get there.
So slow path for me is I'm going to wind up in a general purpose CPU somewhere that's busy with other stuff, some of which may be significantly more important. I think the thing to capture here is, I mean, speaking as a network operator, what I want to know is, how do I configure a policer to make sure that what is entering can be dealt with deterministically, so that I don't wind up moving the potential problem from the edge of the network where I can kind of predict it and deal with it, somewhere into the core where I don't even necessarily know in advance where that's going to be.
So you're saying deterministic processing?
Yeah. So I think the fast path is the place where a given operation can happen at a very, very stable rate of packets per second.
Yep.
And that's usually some sort of hardware device, but I think that's the way to talk about it generically, personally.
We will take the transcript of this session and try and extract useful words.
Tolles again. Maybe we really need to start figuring out a place where we can put together the experience about the issue that we've gained before even trying to come to a conclusion of what the right verbiage is. Let me add the one, I think, high-level data point we got from Multicast, where the forwarding, even let's say without replication, took 4 times the amount of resources than of a unicast packet in a lot of platforms. So what was the impact? The impact was that in a mix of unicast and multicast packets, the average packet size you could do and still achieve line rate was going up, because you couldn't, the total packet rate you could do was lower in the mix. And so then we had to argue, oh, wait a second, so this multicast traffic is all video, so it's large packets, so it actually helps your, but so I don't think that Kiriti's thing, like it can be at a lower packet rate, is something that may be seen as appropriate by operators, depending on what the packets with more complicated processing requirements is. Right. We're now looking only into the options, but I think the problem is general, right?
Yeah.
If there are different forwarding performances, how do we deal with that? And yeah, I would, just to go back to my previous point, just ignoring the stuff, right? Just having some offset of extension headers that a particular platform can choose to always ignore, but not complain about the fact that it needs to skip forward and ignore it at the line rate, at whatever the packet without the extension header has. That, I think, is the one glorious requirement we need to be able to do. Everything else, I think we have a lot of flexibility.
Okay, I'm more on deterministic processing there. So I'll pick up that and I will try and listen to the audio again and make some notes in the issue tracker. Okay, 8200. Oh, this is just for clarification, and we should be much clearer on this. The whole purpose of 8200 was to progress to full standard, and it wasn't intended to do anything to change the spec. And this particular piece of work here is a plan to do some new design work of some sort, limited scope, hopefully, but it's a different thing to 8200. Next slide. Oh. Yeah, we didn't change anything for this because we didn't know what to do. I mean, clearly this is actually the other side of having an extension header is when people write their code for processing malformed extension headers, the code may be incomplete or it may contain a bug because it's not exercised often. If it's in hardware, then that's a little bit more tricky even. And maybe we weren't so smart at the beginning of IPv6. I don't know. I mean, I wasn't in that room at that moment. But maybe we should have been a little bit more careful about this aspect and got this correct. But really, is it an issue now? That would be a good thing to talk about as we go forward. But we didn't change anything yet. Should we deprecate router alert? Question. And Ron Bonica's writing something, so we thought we might wait and see what Ron's suggestion happened to be received. Who liked that? Who didn't like that? So we're not doing anything on that at the moment, leaving that as an issue. Next one. You see, there's many flavors of this because depending on where you sit, you have different versions of not liking this. And I think this is the one we'll try and tidy up if we can by gathering all these together and listening to what people say. So we are listening. Next one. What's the difference between slow path, fast path? And does that become moot in the future? This is slide 13 if you're following on the slide numbers. Brian Carpenter talked about VMs en route being routers and whether generalized network processors will change our thinking about the slow path, fast path. Maybe. I mean, we need to look forward as well as backwards. So it's a useful thing, and we need to find a way to discuss this.
So to insert myself in the queue, so I'm working on a forwarding engine like that, which only has a fast path, and it's an indeterministic forwarding path, fast forwarding path. But I don't know if it makes any significant difference, really. You have the cycles you have, right, at the time you have them. So, Kiretti, please go ahead.
Yes.
Can I say this politely? For real routers, there's going to be a huge difference between fast path and slow path.
Oh, absolutely. That's not what I was saying.
Yeah, I know. So I think that terminology is important to keep. Yes, people are talking about running, routing, forwarding on VMs and so on, and then the distinction will be far less. But the rate at which network processors and special purpose ASICs are growing compared to how CPUs are growing, that distinction will just get bigger.
Yeah. And I think also we have a box size problem here. We have routers which are like bigger than me, and we have routers that can fit in my pocket. And all of these form the path. And if any of these block extension headers, then you don't get extension headers across the path between two users. So it's a little bit tricky to get language right because there are very different views of what a router is. So which ones do we need to change to make this happen, I think is the ultimate question. And we'll get there, hopefully. Yeah, and I will listen to the words you spoke as well.
Good luck.
Ben Madison again. I assume that the implementation that you mentioned a moment earlier was VPP. So, I mean, VPP is a good example of where this becomes a kind of weird nuance. I suppose the thing is, even when you're running something like that implementation on general purpose CPUs, you're still I presume, writing it with a very specific cycle budget in mind in order to try and, as best you can, make that general purpose CPU behave like you had special purpose hardware. And there is still that distinction between this is the path, this is the processing path where I can just execute arbitrary code and I can go into a loop and all of those nice things can happen. And this is the bit where I have a hard stop time. And that will be different for different platforms. And, you know, mostly operators can be trusted to choose the right one depending on how, you know, how hard a deadline that is. But I think I still think that that's the distinction to capture. It's the path in which other stuff won't be asked to sit and wait around while this packet takes its kind of long and winding road down a decision tree.
Okay. Yes.
So Thomas again. Maybe, you know, I think there's a lot of insight gained into these performance characteristics, and I think it's certainly too much for this document. And I think we're just trying to figure out what of that insight we, you know, want to take here for this document. But maybe we should have another document, maybe in routing working group or so. I don't think we'll get away without writing down what we know and don't know about the word slow and fast path. And maybe we should write that down, but in here, maybe just, you know, after this extraction. When you go to edge routers, right, so these very flexible network processing engines, we've done performance tables in terms of from, you know, line rate at 128 bytes down to you activate this feature, you activate that feature, you do this QoS, right? So QoS, transport level stuff, looking into layer 4 ports. It's just a continuous slide down, right? This is all fast path, but still the performance impacts, right, that you have impact the number of subscribers you can put behind that that device, right? So I think it's a lot more complicated than just trying to say slow and fast path in general. And when we do an actual hop by hop header function that is applicable to some traffic, the exact performance characteristic of that has to be part of the discussion about that hop by hop header functionality, right? But here we're trying to do something independent of individual ones. So I think this should be a lot easier than all the insights that we've already gained, and that will become more important when we do individual hop by hop extension headers. Yes.
Sounds promising.
So, Curator, do you want to have the last word on the slow
I was
path
wondering.
first part?
I was wondering when the chair will stop letting me come up here, but I think the binary kind of thing between slow path and fast path is probably good enough. But to echo what Tolas just said, there's a lot going on here, and it's very hard. I mean, we're doing something similar in MPLS and trying to figure out how many different functions you can put, you know, in what we call a special purpose label there, and what effect that would have on the fast path. And then people get into the details of here's the P4, you know, the language that it's like, no, you don't want to go that far, but you also don't want to just wave your hands. So finding the right balance there, I think, is really important, both here and in MPLS.
Okay. So Bob, I will ask Bob, did we hear that fast path and slow path were terms that we want to use again? Or do we have to think about this?
I think we're hearing that they're useful, but they need to be described carefully.
Right. That's what I thought I heard as well. And that sounds a great thing for the issue to finally pin down on one specific issue, and we'll then look at how to get that right, probably outside of the document by just going backwards and forwards and hopefully building towards a definition of what fast path and slow path mean for extension headers. And we probably don't care about the other uses of that term. Oh, go on. Let's have another issue. That is one that's very, very similar to another one, so we're going to close that. What are the incentives for wider support? Yeah, I mean, we've already started touching on that, and I think we will form an issue here which will probably go for a little while, which is we should try and explain what hop-by-hop processing is actually useful and why it might be, so that we can motivate people reading this draft and doing something different. Otherwise, the status quo is maintained, and we don't have support for hop-by-hop extension headers because people have already started blocking them. So if we don't explain what are the incentives for wider support, then we won't get anywhere. But we need contributions of text, and we'll put them into the issue.
There's a man standing in the room which is not in the microphone queue. I don't know quite who it is, but he should press the button.
I would always say the first thing word to have in there is must be able to ignore, right? Should be able to process is secondary. Must be able to ignore, I think, is the core thing for interoperability, right? So, because I think everything we're doing is going to be optional and so that I'd really love to see that must ignore support the size as the core.
And that was Toiler speaking again. Okay, we've done issue 17. And we'll look at the next issue, please. Issue 18. We can stare at the one chair who's sitting in the room and say, at the end of the day, are we going to make recommendations, or are we actually going to make requirements? Should this be a standards track document? And we'll keep asking him until he decides. But I guess that will be depending on how the document goes. But it's a useful question because depending on how strong the consensus is, we should make recommendations with a small r or recommendations with a big R. Yep. He says yes, that's good. Number 20, we can't expect unrelated routers of devices on the path to apply specific behavior. Yeah, extensions headers are an obvious way to extend IP features. And I guess we live in faith that we can extend IPv6. I think it would be a good thing to do personally. And we agree that a specific hop-by-hop option will only be processed by nodes wanting to do so, which is kind of a little bit like we've heard today. Don't think we can change that. So maybe this is a good comment, and maybe what we'll do is try and put that into the document a little bit more clearly at the beginning. Issue 21, new options must not be defined that require slow path processing. It seemed simple, but and then some people didn't like that one. So that would be an argument of having routers on router alert. And to stop us going further, there's a URL to the issue tracker, which is where all this stuff really will be best discussed. So, end of my talk.
You have 7 more slides.
I do. I can carry on talking for a long time.
Your backup slides. I think we're out of time. So,
Yes.
any further questions? I think you've got enough comments and questions to work on the next revision. Yeah. Happy.
Yeah, this has been very good. Thank you all.
Bob, you get to say a final word as I sit down.
I thought I just did. So the next, so we're not doing Tom's talk. So now Jai Dong will talk about VTN ID.
Me?
So,
Hello?
G, please go ahead. I can give you
Okay.
slide control as well if you like.
That's fine.
Yeah, so now you should be able to control the slides. So please go ahead.
Okay, thank you. So this is an update about carrying VTID IPv6 extension header draft. I'm presenting on behalf of the co-authors here. Okay, here's some background and the status of this draft. Basically, this document proposed to introduce a new hop-by-hop extension header to carry the VTE information, which is used by the transit nodes on the path to steer the packets to the set of network resources allocated to the VTN to provide the guaranteed performance for the VTN-specific traffic. And the current status is this document has been adopted early this month. And during the adoption call, we received valuable comments and discussions. And many of the comments have been resolved in the mail list discussion. I think it's a good way to list all the issues, just like the previous draft did. In this presentation, the authors mainly would like to pick some of the comments for some further discussion. And we can hear more feedbacks from the working group, so that the document will be updated accordingly. Okay, here's the first comment is about the terminology. during the adoption call, there's some discussion about whether we call it VTN resource ID or the NRP ID or something else. I think this is related to the terminology discussion and definition in the TIS working group. And in TIS working group, the NRP or network resource partition is defined as a set of network resources allocated in the network. And the VTN, the virtual transport network, is a virtual underlay network, which is consisting of a set of network resources and associated with a network topology. So it seems that the VTN resource ID and the NRP ID refers to the same thing. And currently, the TIS working group is working on the alignment of the terminologies in a set of drafts. And this document could follow the decision made in TIS to do the terminology alignment. But something more to be considered here is that whether we want to extend the semantics and the format of this ID for the hop-by-hop extension header. This will be discussed in the following slides. Okay, the second comment is about the processing procedures. The first one is if a node skips the hop-by-hop extension header, it cannot apply the policies required for the VTN. So this is this is a reasonable comment, and our response is that if strict conforming to the VTN specific processing is required in the network, it is recommended to make sure that all the nodes involved in the VTN can process the hop-by-hop and this VTN option. This the capability of the network nodes can be obtained either via the management system or some control plane advertisement, so that we can make sure that the traffic will only be forwarded to the nodes which have this capability. Another thing related to the processing is how to process the packet if the transit nodes it can parse the VTN option, but it does not have the network resources allocated to the VTN. This is something we need to consider, and currently we think we may use a flag to determine the forwarding behavior of in this case. When the flag is set, it will indicate that packet should be dropped when there's no matching resources for the VTN. If the flag is not set, it will indicate that packet can be processed use a default set of resources, like it will fall back to the best effort processing. The third comment is about the semantics and format of the VTN option. We received comments and suggestions that to make this tag generic and flexible, because in addition to the network slicing, there are other use cases which could benefit from this tag. And there's also following comments about whether we need to consider to allow the variable length of this tag and whether we should introduce some structure to this option. So here are some considerations from the authors. The first one is we think the semantic of this ID is like a network-wide identifier. So if anything which is network-wide has some network-wide semantics may be carried in using this ID if it is generalized. Another thing is we need to consider to align with the processing suggestions and the guidelines in the hop-by-hop processing draft. The first one is we need to make sure that the option is straightforward to process, and the length of this option should not be extremely long, which may extend beyond the capability of the nodes and for the fast path processing. So taking both into consideration, we considering to make some extensions to this option to keep some extensibility and for the future use. The option data length field of this option can already be used to indicate a variable length option field, the value field. And we may introduce a flag field for the behaviors indicated in the previous slide and other optional behaviors, even processing this identifier. We may also introduce a reserve field for some future extensions. The last one is whether we consider to make this ID field variable with a variable length. Taking the discussion about the fast path processing, we need to be careful about making the length with arbitrary length. So this need to be discussed.
Pascal, do you have a comment?
Yes, my comment is, thank you, Bob. My comment is the need to signal a logical topology for which there is a state in the nodes appears in multiple places. We've done already a hop by hop header option for Ripple. That's the Ripple option, and that's exactly what it signals. There is what we call an instance ID, which is a logical topology that basically you place the packets on. Right now at DetNet, we also have the need to signal something like a path, which is really a complex logical structure on which the packets will be forwarded with the exact same needs that every node on the path must understand the topology and forward based on a DetNet state, which is associated to that topology. And so I was like, are we going to create one option per work group, or is there an intention, a need to kind of recognize this common requirement to identify logical topology and the state associated to that logical topology? And so we would basically have consume less options basically in the option space. And how do we want to handle this?
Yeah, very good question. I think from the beginning of this document, we can see that it is mainly about the initial idea is to use this option to identify a virtual transport network and the set of resources for packet processing. About in the adoption call, we received this comments about whether to consider to generalize it. So the authors, I think, we are open to the discussion in the main working group and any consensus based on the discussion, so that I think it's up to the working group to decide whether we make it a generalized option or we keep it for a specific usage. Okay, shall we continue?
Pascal, do you have a further comment before we move on?
Yeah, I mean, it's not a further comment. It's really, I mean, I'd like feedback from the room actually, or from people. So do we have a direction? Is there any intention to lead to many options or more coalesced ones? I mean, is there like an architecture that we'd like to follow as a group?
Yeah, it's a good question. Okay, let's go on.
Yeah, okay. Okay, so here's the next steps. We would like to collect the further feedbacks from the working group on the above discussion points. And if we have some consensus on any of them, we will update the document accordingly. Okay, that's all.
Thank you.
Thank you.
Any further comments? If not, then we are moving on to Brian Carpenter's presentation, who's sensibly enough not stayed awake, but sent us a video. Sorry, Eric Klein, you can speak while I get the video up.
Oh, I was wondering whether the APN folks had a chance to look at the extended VTN comments and to know what to decide whether or not it would work for them. I don't know if they're in the room. I know they have like 5 minutes at the end of the session, time permitting. Anywho, never mind.
Yeah, that's certainly an interesting question to keep in mind when we talk about APN. Let's see.
Okay, so you'll
This is the first time we're sharing a video, so let's see how this goes. Please don't interrupt, Brian.
Hi, this is Brian Carpenter, and I'm going to talk about the ID on representing IPv6 zone identifiers in uniform resource identifiers. So first, a bit of motivation. Literal addresses in URIs are mainly intended for operational use or diagnostic use, not for normal use. Sometimes we need to take actions relating to IPv6 linked local addresses on a specific interface on the host. A web browser may be the handiest tool for this, for example, just to send out packets that you might want to trace. And it may be the only tool for actually reconfiguring devices whose configuration mechanism is a built-in web server if they're otherwise broken and need to be hand reconfigured. And there's at least one application, CUPS printing, that needs HTTP usage of linked local addresses on a specific interface. So the use case is quite real, even if not very mainstream. Well, we did discuss this 10 years ago, and it became RFC 6874. And now the question is, why are we discussing it again? Well, because that RFC was a fail. As you know, we have a standard text representation for a linked local address, as is shown on the slide. That's widely supported and used in IPv6 in general. So RFC 6874 defined a mapping for the zone ID in URI syntax. No known current browsers supported. The browser community, the WOT working group in other words, decided explicitly not to support it. So what were the problems that produced that failure? Well, it modifies the ABNF of the formal definition of URIs by adding in this new component, a percent sign followed by 25, followed by the interface name. You use %25 as a separator because that's the method in URIs, according to the syntax, of escaping special characters such as a percent sign. Now, the problem with that is it prevents cut and paste. You can't cut what you've typed into a ping command and paste it into URL. You have to manually fix it. We previously proposed that because that is the escape character in URIs. But when you actually look into URI parsers and how they work, it turns out you really don't need it. So the proposal with the new draft is simply to drop the %25 and replace it with a simple percent sign. Another problem is that the text of 6874 requires hosts to delete the zone ID from outgoing URIs. That would be in an HTTP host header, for example. That violates the normal behavior of HTTP implementations. At the very least, it's awkward to code, and it actually breaks one of our use cases, namely the CUPS printing protocol. So the proposal now is to simply delete that requirement. Third problem with RFC 6874 is it suggests that URL parsers should support the %25 encoding, but heuristically accept a URI that doesn't contain a percent encoding. So %eth0 would be recognized as the same as %25eth0. except for the exception cases where percent sign could be a legitimate escape. It makes it very tricky to code. It's very confusing to users. So the proposal is to delete this suggestion. And the fourth problem area with RFC 6874 is that it forgot to update the internationalized resource identifier syntax, which is trivial to do, but it means doing an update of a different RFC as well as the original one. So we end up with the final proposal, which is that parsers, whether they're parsing URIs or IRIs, should accept a literal address as shown there, which simply has percent and the interface name. The zone ID should, of course, be passed on to the socket API without any need to validate it. And there are no other special requirements for browsers. All the other special stuff we discussed in RFC 6874 is dropped. So we need feedback. We contacted a number of senior people in the browser implementation community. The message back from them was very clear. They could implement this, but they will not implement it without strong pressure from users. So our conclusion at the moment is that the best course of action for the IETF is to advance this draft to precisely document the required browser behavior and then wait until that strong pressure from users arrives, which I think it will do as people deploy IPv6 only networks and discover they have no other way to carry out certain operations. Of course, we, the authors, would prefer to receive lots more feedback. Thank you.
Thanks, Brian. Any comments on that? Anyone representing the browser community here?
Yeah, so I'll just say I seem to have been a co-author of this, that I think our goal is to document what we think the right behavior is and thinking that this will be useful later when there is demand for something like this. Currently, right now, there isn't. We have someone in the queue.
Mr. Ackerman, can you go ahead, please? No, you're just hang on. Yeah.
Oh, yeah. Watch it, everybody. Mike Ackerman. I have a first off, I think this is great work and can get rid of some inhibitors. I'm from a large enterprise who's not doing IPv6, and this is one of the reasons why I kind of. So this is great work. In Brian's context, there is an organization like mine considered a user, and should we apply some kind of pressure here to our vendors, or should we just sit back and?
Please.
So that's my question. What can we do to help? Kind of question.
Yeah, I think showing that you're interested in this to your as a browser user customer sounds fine to me.
And just to give my perspective, what happens to us is I'm one of the ones that wants to do IPv6. Very few do. And when I say, okay, if we do it, here's the ways to do it. Here's how we can help and everything. But here's a couple minor issues. A lot of people don't think this is a minor issue. So that it's an inhibitor. So thanks for trying to address it. Anything we can do to help, let me know. Thank you.
That's good feedback. Thank you.
Michael Richardson.
Michael Richardson at the mic, having reloaded his entire browser tab to get back to the thing. I expressed the opinion a couple weeks ago that there was no point in doing this until we had we were just spinning our wheels. Brian's convinced me that it is useful to go ahead. I am very skeptical that groundswell of user demand will appear due to chicken and egg, because no one's going to bother deploying an IoT device that's accessible by IPv6 link local literals until browser can reach it. Okay, so you know that's I unfortunately I don't know how to break that egg. And what I was hoping is that somebody, maybe an enterprise user who has a close relationship with their browser vendor, will cause at least one browser to do this, and that may maybe break the logjam. And I think that the example of in a home specifically, which has been renumbered. By renumbered, I mean someone else has moved into the home, and now they have a whole bunch of devices that are effectively have names, and maybe they have IP addresses from the previous owner. And now that you need to actually go and find these devices and do something with them, and this is where it really, I think it's a real win for that. But until maybe someone's going to have a you're going to have a specific compile of a specific browser that actually can find all your old devices. But anyway, so the point is that I was on the skeptical. Should we do this work? Should we publish this? Is this worth the AD's time to review? And I'm convinced that I've been pushed over to the side of, okay, I guess it's worth doing something, even if the browser people won't help us.
Thanks,
Good,
Michael.
thank
I'll
you.
let Ben sneak in because he claims that his browser isn't working. But
I did try again when you put the QR code back up. It's still not working, I'm afraid. So speaking as someone who can't really think of an immediate use case that I have for this, it seems like it's probably helpful for someone. The thing that occurs to me is it seems like this is potentially an avenue for either kind of reconnaissance or data gathering via the back door. If you manage to get a browser or some other piece of user software to follow a URL of this form, you potentially are able to gather data that kind of listens only on a linked local address under the expectation that that data is only going to be available locally. And I wonder if you've given any thought to whether this makes whether you need to start thinking about degrees of trustedness, and whether these these qualified URIs need to be treated as inherently less trusted if received from a remote source than a kind of a normal DNS name based URI. It feels like there might be a bit of a can of worms down there.
Okay. Yeah, I don't think we've thought about that. Thank you.
Lorenzo.
Lorenzo Calidi. I think there's value in documenting the correct format. I don't think anything will actually use this in URLs because the thing that hands out the URL is an HTTP server usually, and the HTTP server doesn't know what interfaces are present on the client, kind of by definition, right? So it's useful. Like, how does my IoT device know that my interface is called ETH1, right? But anyway, like I said, I think there's value in documenting the correct format. I think it's primarily useful for users like typing URLs in manually, which users won't do, but it's probably useful for debugging.
Yeah, we need to wrap this up soon. We're about out of time.
So perhaps it'd be helpful if I gave an example of the kind of thing I think this might make work. So systemd, for example, uses heuristics and information about the PCI bus that a NIC lives on to generate an interface name by default. By asking someone via some embedded JavaScript to go and try FE80::1 via a series of kind of constructed interface names, you might be able to gather information about what NIC someone's got on board. That sort of thing is, I think, the stuff that this potentially enables.
And you get the last word, Michael.
Thank you, Michael Richardson. Lorenzo's question about IoT device. Well, in most cases, what's going to happen is that you need to get to the beginning page of the device. You get that by essentially scanning the network using MDNS or something like that. So those links are actually created locally. And once you get to the page, the links are all relative. So you don't have to worry about the device knowing which thing it is. This is a mostly solved problem, and if anything, there's some security concern about if the page does come back with some interface devices, and but I think that's a what's the right word? Cross-site scripting issue that is in general is a problem, not specifically to this.
Okay, thank you. Let's go to the next talk. Suresh, you're up.
You should have slide control as well, Suresh. Let's see if Suresh can sort out his audio and video. So this, by the way, is work that we asked Suresh to help us with as a working group in collaboration with Spring. So this came out of a work in Spring where the Spring chairs asked 6Man their opinion on the usage of V6 addresses in Spring documents. Suresh, do you want to give a little wave or hint of where you are? Otherwise, we can move to Ted's talk and come back to you, Suresh. Yeah, why don't we just move to, should we do Ted's talk first and then Suresh, you can come after?
Just want to try see if this works. I just left the room and entered.
Yeah, we can hear you.
Yeah, now we can hear you.
Okay. I think I lost the slides now.
Yeah, let me share those again.
Thank you, Ole. Thanks all. And I was going to complain about like it being very early. Then I realized Bob is like 3 a.m. for Bob. So like I'm going to stop my complaints.
Thank you.
Thanks. And Eric as well. So thanks. So thank you very much. Like this has been like a very interesting draft. Like so this came out of as like Ola said, like a lot of discussions between the 6-man chairs, the Spring chairs, and the respective ADs as well. So I just put together like a kind of a straw man proposal to go forward with, trying to address like all the points that were brought up in there. And next slide, Ola. Thank you.
I gave control to you.
Oh, excellent. Thank you. I think that's the part I lost the audio, so thank you. So the goal of the draft is to look at the characteristics of SRv6 SIDs and how they relate to the IPv6 addressing architecture. That was kind of the ask of me to do it. And like one of the things that came up was really the SRH like SID list that's in there, right? And so it is like, I think it's pretty clear from the SRH RFC itself, right? Like, there's like different kind of things that can occur in this list. Some of them are like SRv6 SIDs, and the other things are just addresses that can be assigned to local interfaces, just like any other IPv6 addresses. And what this draft clarifies is like anything that falls in the local addresses assigned to local interfaces scenario needs to comply with RFC 4291. So like, how the address is formatted, how like, the ND works and so on, needs to be fully in compliance with RFC 4291. So we are really talking about like, what's in B. And so the draft like looks at like how like RFC 8986, which is the SRv6 network programming, defines the SRv6 sets, right? So it's got like this 3-part thing, like, the lock function arguments sitting in there. And this clearly does not follow RFC 4291. So the idea is to really document this deviation and to mention that these are not acceptable for assignment to n-hosts as on the interfaces. And clearly, we do have precedent for doing stuff like this. So the 6052 is like for addressing of like IPv4 to IPv6 translators, and 7343 is like this ORCIDs, which are crypto IDs, and they don't follow RFC 4291 either, but they look like IPv6 addresses. So like what we're saying is like, hey, this thing follows the same path as this other things we've done before, which don't follow 4291. So don't assign them to interfaces on end host. And the other piece was like, how does this affect stuff that does not is not aware of SRv6, right? Like, it doesn't do SRv6. So for the nodes which don't support SRv6, these addresses, like when they appear in the destination address of the packet, they're just used as like regular routing addresses, right? If you look at RFC 7608, like which talks about variable and prefixes, it's like Brian's RFC, right? It really talks about like, you can have routing prefixes of any length. So like, you just need to make sure that like what is in the locator part like kind of doesn't change going forward. So it's simply just a prefix, and that's really the standard to apply here. So what does the draft recommend, right? It just says a few things, right? Like, and one of them is to come up with some kind of like address allocation, right? It requests a prefix allocation from the IANA space for this, from the global unicast space. And the idea is like a lot of people have said like, hey, like, when you have a packet, especially without an SRH, like doing SRv6, it becomes like difficult to do filtering at the edges because you don't really have an SRH to look to see if this is like doing SRv6. So this allows like, people who don't want these kind of packets to escape the domain or to enter the domain, depending on like, where you look at, it helps identify these kind of packets to filter them at the edges of the SR domain. And it also talks about like few things that the compressed draft, which is what caused this whole like exchange between Spring and 6-man, as well as the routing and internet areas. It has like some stuff that needs to get fixed before it's published as RFC. So it talks about a few of these things, and especially really about error handling and OAM and like how the segments left field is defined. It just says like, hey, you need to fix these things. But obviously, it's not up to 6-man to decide, but I think it's some indication like for the ADs to look for these things when this hits the IESG. And the last piece is like, pretty much, I think it's obvious and doesn't need to get said, but it's worth documenting. Is that like generic IPv6 tunneling security considerations apply when you use these addresses, especially when like you don't have like SRH or like tunneling happening. You still have the same kind of concerns because you could get into a domain and direct packets in a specific way to hit specific nodes. So I think the security considerations still apply. So that's pretty much what's in the draft. So if you haven't read it, it's like a pretty easy read. It's like not very long. So please go ahead and send comments on it. I got some extremely good comments before. Special thanks to Brian Carpenter and Eric Klein for like a lot of the thinking behind this, and like Bob and Ule and Andrew, like Bruno, like a lot of people gave like really good comments on it. Too far to name. They're all in the acknowledgement section. So please feel free to reach out to me or like go on list if you have any issues with it. So thank you.
Thanks, Suresh.
So yeah, thanks.
So we have Jen in the queue.
Yeah,
Hey,
Jen
Jen.
Linkova. Suresh, clarification question. But you're saying global unicast, so you mean 200/3, right? Is there any
No,
reason not to use something which is like more like bogan/reserved address space, so it's never gets confused with like proper RIR allocated addresses?
Yeah, so this is not coming from the 2003 gen, right? It's asking for a specific new allocation.
Because I was maybe I confused. I was thinking that we're defining global unicast as 200/3. So maybe we need to make it explicitly clearer, so it should be outside of that block.
It is, right? Like I think specifically asked for F016, right? Like
maybe
it's specific. Yeah, it is like specifically outside the block. Thanks for. I think if I had to make something clearer, like I will, right? Like, but it's an address with global unicast semantics, but not from the currently allocated global unicast block. So I think I can probably yeah.
Cool. And yes, like need maybe in IANA consideration, maybe we should explicitly say that it should be source through destination through globally routable false or something like that, so we're clear on what is expected in terms of routing that.
Sounds good. Thanks, Jen. Hey, Jen, if you can send me some text like from the IANA consideration, if there's a diff, like I would love it. Thank you.
Yeah, sure, we'll do.
Thank you. Thanks.
And we have Ron in the queue.
Hey, Ron.
Okay, hi. A question about the scope of the draft. I realize you were focusing on addressing architecture, but there were some other places where we might get in trouble with 8200. As an outgrowth of the CSID, I believe there are some situations where you might have a SRH, a routing header, that has no segments in it. You just need it either to separate destination options that come before and after, or you might need it to carry tags, flags, and TLVs. Is that something we should talk about in this document?
So right now it's like a good question, Ron, right? Like, so right now it's like saying to the CSID draft to document this, right? Like, how the segments left field is handled, because it's clearly noted as a deviation, right? Like, especially when the segments left close to 0, right? Right now it's in there. Like, if you want to have some kind of discussion here, I'm perfectly okay with it, right? Like, to add some further meat on it. And thanks, Ron, for your comments as well. Like, very helpful. Okay, from before.
Okay, yeah, we can do that offline.
Certainly talk about it. Yeah, yeah.
Yeah, we can do it offline.
Thank you.
Okay, good. I think Oli and I will start an adoption call after the meeting or next week, something like that. And we can go from there.
Thanks, Bob. Thanks, Ole. Thank you. And
Thanks
like
a lot.
really
Thank
nice
you,
to see a lot of
Suresh.
people. Too bad I couldn't be in Vienna, but like maybe next meeting. Thanks.
Okay, so I think the next talk is Ted.
Ted.
Yeah, I'm out. This Apple thing that I have only have 4 USB ports, and all of them are used. So I'm afraid you have to say next.
All right. Well,
don't know what company you represent that could do something with that, but
unfortunately, I'm not in the hardware group, so I can't help you with that. But yeah, they do make hubs for that, but I wasn't going to say that.
Ted is very faint.
Sorry, this is the mask. Can you hear me now?
Better.
Okay.
Thank you.
Yeah. So the reason that so this is a discussion about the source address selection policy for foreign ULAs, and I will explain what that means in the presentation. Could I have the next slide? Okay. So imagine you have this scenario. This is not the only case where this can happen. This is just an example scenario that I can use to illustrate it, because this is something that actually occurred and I got a bug report for. So you've got a home network, and you've got a reasonably competent user on the home network that has set up a router with an internal network. In this case, they were using it for testing of software. They wanted to make sure that various things could communicate over a router. So they set up a router. You can see the router on the lower right-ish that is manually configured to advertise a ULA PIO option on the internal network. And you have a host on the internal network in the far lower right that has gotten a ULA address. And then you have a home network, and the home network just has a GUA. And it got the GUA from the CE router, and there's a host on the home network that has the GUA configured. So in this configuration, the router, the internal router, is advertising reachability to the FD12:3456 ULA using a router advertisement, and host 1 sees that. And CE router does not see that, because CE router is a router, and routers don't listen to router advertisements. So next slide. So when we try to send a packet from host 1 to host 2, this is what happens. The source address selection chooses 2001 OC001 because that's the only choice. It sends it actually, it sends it to the internal router. Next slide. It sends it to the internal router based on the router advertisement. So actually the CU router, that's a mistake. Next slide. The internal router forwards this to host 2. Next slide. Host 2 composes a reply and sends it back to the source address that was selected. Next slide. Now, probably, so the internal router may have actually been configured to have a static route to the GUA, or it may just send it to the CU router because that's the default route. Either way, it works, right? CU router, next slide. The CU router would send it to host 1, or maybe the internal router would send it to host 1. Either way, this communication all just works, right? We don't have any kind of routing protocol running in the network. CU router and router are not talking to each other. This is all statically configured, but it just works. And it's a reasonable thing that you would expect somebody to do and expect to work. Next slide. Okay, now imagine that you add a stub router to this network, and the stub router advertises another ULA on the home network link, not the internal network, but the home network link. Okay, so now host 1 has 2 addresses. It has the GUA and it has a ULA. Next slide. Okay, so host 1 wants to communicate with host 2. It still knows the address of host 2, and so it sends a SYN packet to host 2. Next slide. CU router knows how to get to host 2, we're assuming. So it forwards that packet to the internal router. Next slide. The internal router sends it to host 2. That's all fine. Next slide. Now, I think I skipped a step here, but anyway, the host 2 sends it back to the address that host 1 selected. Next slide. And CU router very sensibly says, I don't know what that address is. I guess I'll just use the default route, and it sends it to the internet. Or hopefully it filters it, but let's be real here. So basically this fails. And now all of a sudden, because I've added this new router that we see on the sort of on the right on the home network, because I've added this new router, which is doing something completely legitimate, it's just advertising a PIO option with a new ULA in it, suddenly the whole network configuration is broken. So next slide. So the problem here, if we want to agree that it's a problem, and the reason I'm presenting this is because I want you guys to know what I saw, and ideally this working group would decide whether they think this is a problem or not, right? So the problem that I see here is that because we have 2 dissimilar ULAs, source address selection makes a decision that winds up breaking things. And the decision it made was a perfectly sensible decision. The configuration here, I think, is perfectly sensible. The statically configured router is perfectly sensible. Having another router advertise a ULA using an RA is perfectly sensible. And yet it all blows up as soon as we do that. So should we do something about this? Next slide. Okay, so one way that we can think about this is that automatic behavior shouldn't break things. So when something like this happens, we should make sure that it works correctly. And the way that we would make sure it works correctly, one way would be to have routers listen to RAs, which I suspect would get a big boo. The other way is to have source address selection not treat ULAs that have foreign global identifiers as being close, which it currently does just because of shortest match, right? So if we care about this, then we probably need to specify a little bit of additional detail about how to deal with source address selection in the presence of foreign ULAs. The other way of thinking about this is, well, this was a manually configured network. There wasn't any automatic protocol happening. If we'd been running a routing protocol, I don't think this would have happened, because presumably, although, you know, maybe it would have happened, because just because we're running a routing protocol doesn't mean that when you plug another device into the network, it's going to be participating in that routing protocol. So, but the main problem is, like, the person that did this is a very, very knowledgeable networking guy, and he had no idea why it broke. So I kind of think it might be nice to fix this, but you know, I've had some pushback saying no. So I'm just curious what people think about this problem.
So, Michael, you're first in the queue.
Michael Richardson, can you go back a bunch of slides? I don't know where, but to before the ULA router was there, maybe. It doesn't really matter in the end because the picture is good. So I actually don't understand how it worked in the first place.
Okay.
And that's actually I think it's fundamental because I don't understand how it worked in the first place. As far as I can see, it should all have been broken always, not just when you added the ULA router.
Right.
Okay.
So,
And I think it's good if it's consistently broken, then we can agree that there's a problem, but the problem might be bigger than just adding the ULA router.
yeah.
Okay. So first thing I'm going to note is that CE router is not compliant to whatever it's called now, 7204, I think it is, 68. The CPE IPv6 CPE device requirements.
Okay.
Okay. Because it's not advertising ULA on the home network. It's always supposed to be advertising ULA on the home network. So that host one should always have had a ULA there. And I think if what you're telling me is all correct, then the host would always never have picked its GUA to talk to host 2.
Right.
Okay. So I don't know why that didn't happen, but you can turn that off as it is allowed, but it's supposed to be always there. So what that really means is that there's always a ULA stub device supposed to always be there, and whatever is broken should always be broken for the situation.
Well, okay, that's not a completely invalid statement, but I'll point something out here, which is, if I were a naive but reasonably knowledgeable network operator of
Right.
my home network, and the CE router were advertising a ULA, then the ULA that I would use on this internal network ULA would be the same ULA, right?
Why? They both should randomly produce one.
Well, okay, so let's say they both randomly produce one. Well, now, and then suppose I configure the CE router to forward to that address.
Is that what happened here? Because I'm really unclear about how the communications from host 1 to host 2. How did I don't understand how it found about that FD12 ULA.
Right. So there's two ways that could work. Right. One is the router is advertising an RIO.
Yes.
To that ULA.
Yes.
That's one way that could work.
Which means that host 1 saw it because it listened to that.
Yeah, right.
It didn't configure an address in it because it's not on link, etc. Blah blah blah.
Right.
But it saw that.
Yeah.
So if you go forward, Ole, I think you need to go like 3 or something forward where we have the ULA router.
See, there we are.
Okay. One more maybe.
Uh-oh.
There's a bit of a delay.
Yeah. Go out to the around the world once before we get the result. Why did host 1 send it to the CE router since it knows about FD12? Back one. But why did it send it to the CE router here?
Yeah. So there's two ways this can work. One is the CE router is statically configured with a route to that network, and the intermediate router, which has disappeared, is not advertising an RA, right? And in that case, the default route would carry it to the CE router. The CE router would know that it needs to send it to the internal router.
It wouldn't have sent it out to the internet at all anyway.
It would, in that case, it wouldn't send it to the internet because it has a manually configured route to the internal
Right.
network.
So we agree that if the CE router has been clued into the other network, that everything is good.
Yeah.
And I agree with you that shouldn't necessarily be the case. That device might be belong to the ISP. It has no management interfaces. That's why I put the other router in the first place. I want to do something, whatever. So, but I don't understand why the host 1 sent it to the CE router when in the previous case.
Well, so I think you're nitpicking my slide and not actually asking a real question here.
Okay.
Right. The slide. I think it may have been a mistake that I said that the host sent it to the CE router. I don't actually know the detail of that, but that's why I'm saying there's two ways it could have worked. One is the CE router knows how to get to the internal network, and the other is that the internal network router is advertising the network. Either way, the same thing happens.
Well, I disagree. That's just the point. What I'm trying to say is that I'm not convinced there's a problem, that isn't caused by a series of misconfigurations, not just one that the the guy manually configured that, because you asserted you did it correctly, and I agree with you, you did it correctly. Okay. So I'm not convinced that the behavior of the other devices on the network is correct. That's why when we have this conversation, I tried really to draw your diagram so that I could be really sure what the problem was.
Right.
Okay. And I think actually, in the end, I don't object to making the source address selection rules more sophisticated, because I think that they cover cases that are harder to explain with one diagram. I just think that we have to articulate why we're doing it better, so that and this case has to be clearly clearly a problem, so that the solution is clearly motivated. Otherwise, people are going to come back and say, well, but like I'm doing right now.
Yeah.
Okay. And that also may mean that when they test it, their code in the field, they'll set things up wrong.
Yeah.
And either it won't work and they'll complain that we're idiots,
Yeah.
or it will work, but their code is wrong.
Yeah.
Okay. And they didn't actually implement it properly.
Yeah. Right. So I definitely agree that we should get the problem statement more crisp, and I apologize for being unclear on the slides.
And I just want to, just for the room, I know what Ted is doing with the ULA router and the stub network, and that's really, I think really important. But that also could be another CE router.
Yes.
Whose internet link is broken right now.
Right.
And the reason I had two of them in the first place is because both of them are not that reliable, right?
Yeah.
And I recently had a 24-hour outage that couldn't control. Right.
Okay, we have two more people in the queue. Martin.
Hi, Martin Huniek. I also want to say that it's probably a configuration issue, because the CA router should have a ULA, and probably the internal network should be part of some bigger ULA prefix.
Well, so I don't think that's actually an interesting criticism, though, because this is a perfectly valid configuration for a network. Whether or not this is a CE router is not really the point. The point is that it's entirely possible for something like this to happen. And if it does happen, do we care if the network breaks or not?
Yeah, but the CE router should, as stated before, should have a ULA also set up.
Yeah, I get that. But what if it's not a CE router? What if this is in a corporate setting, and somebody plugs one of these devices into the wire, right?
I don't think it's something that should happen or should. Yeah.
Well, so what I'm saying here is that suppose you set up a network that, like in an enterprise setting, you set up a network where you have a router, you have an internal router, everybody configured it right, everybody thought they were doing the right thing, and now somebody plugs a new device into the network and the network suddenly stops working. Is that okay?
Yeah, I would say it's in this case it's okay, because you should have put there the ULA.
Which ULA?
In this home network segment.
So there should have been a ULA on this wire here coming from this router.
Can't hear you when you walk away from the mic.
So there should have been a ULA coming from the CE router, and therefore any problem that occurs that's the result of the CE router not advertising a ULA is not a problem.
I would say so.
Okay, so what if it's not a CE router? Yeah. I don't think this is a legitimate, like this is something that can happen without anybody doing anything incorrect. Right.
All right, let's go. We have two more people in the queue. Lorenzo.
Yeah, Lorenzo Calidi. I mean, this is why ULA is a terrible idea in general, but I think so. I don't, to be honest, I don't see any good answer here other than like have the router listen to arrays. And the reason for that is if we change the source address selection rules to basically say that ULA is scoped to /48s. First of all, we'll never get that through because people believe that ULAs are global, but they're not. They're actually just net 10, right? So we'll have it, like, it'll be impossible to actually change that. But even if we did, we're going to break a bunch of legitimate use cases where networks have separate listing QLAs and they rely on this behavior to work. So I think that's a non-starter.
Okay.
And so in practice, I don't see that to me, it feels like if we expect it to work, that you plug in a router and it sends an RA and it sends a PIO and an RIO for itself. If we want that to work, then we need other routers on the network to listen to that.
Right.
And I think that's the only thing. And it's not true that routers don't listen to RAs, because the CE router at the top there, which ostensibly shouldn't listen to RAs, got its default route via an array. So it can't be like that sacred that it's not allowed to do it.
Yeah.
It's very difficult to implement though, because for the Linux boxes that these things generally use, you have no easy way to filter out certain routes. You can't say only accept ULA. In fact, there's the connected home people would like us to do that, but we don't know how to do that. So,
Okay,
yeah.
we have
Okay,
several
so
more
that's a
people
good
in the
point. Thank you.
queue.
So
We're
can
going to
we-
close the queue after Eric.
So Ackerman, can we do the insertion before? It was a tooling problem, so if yeah.
Oh, okay. No.
Yeah. But stand in front of Jen. Yes.
Sorry. This is real quick. This is Nalini. So just Ted, just one small comment about introducing or plugging a router into an enterprise network, and maybe this is what Mike was going to say too. Yeah, you're not doing that. Yeah, no,
It really,
you're not doing
no,
that.
we're not doing it to your network, but
No. To almost any
Nalini,
network
Nalini.
of interesting. Yeah.
any Soho network could be configured this
And
way,
more
and
than
that would
likely,
be a
we'll do
reasonable
it to our own network, which is
Yes.
kind of what I was going to say. So I think this is really good work, good finds here. So thank you, Ted. I'd like to see this continued. Nobody can hear me. So please do, because I can see this happening on our network.
Yeah.
And again, another dumb enterprise question is that we think, when I talk to people that want to maybe do this, EULAs seem to be important to them. And there's levels of assumed control and limitation that don't seem to be applying here. So yeah, if you can get that under control, that would be fantastic. And one more thing, you showed one slide where with the CE router, we're supposed to route it over to host one, send it up to the internet. That concerns me too. So
Yeah, well, that shouldn't happen, right? The CE router should not be forwarding ULAs to the internet. But I think
Okay.
that,
But isn't there some definition issues? I think Bob is working on this where we're defining what the limited domain of a EULA is.
Yeah,
and
yeah.
that's not clear to me. And maybe that needs some work too.
right. It seems to me like there probably is an ops document to write here. So maybe this isn't even a 6-man problem. This is a V6 ops problem.
Good stuff. Thank you.
Okay, Jen.
Jen Linkova. So I still need to get my head around how exactly this happened, but I don't think it's a configuration issue. I think what we're dealing here with is trying to use arrays as a routing protocol. Like we're trying to use ND as a routing protocol, right?
Yeah.
So I think if you want something like that, right, we need to explore how to do it right, but I don't think changing default address selection algorithm is the right way to fix a particular topology, because I can come up with 5 other different cases when we should not be doing this. So I agree this needs to be solved. I don't yet know how. Maybe array is the right way of doing this. Maybe we need something, I don't know, like what HomeNet was doing, whatever. But I disagree that like ULA's particular case is the right way of doing this. Because actually it might not be ULA necessary, right? It might be something, it might be actually legitimate like global unicast addresses, and I suspect you might have similar problems.
I think this is why I brought this here, because I figured people would point out like, stuff like this.
Okay, Eric.
Thank you. Yeah, Ted, I just wanted to offer that I think this ULA router that got added, I don't know what its function is. I know others do. I think it probably should advertise the ULA inside of a PVD-IO. It's a separate provisioning domain within the home. And it's not.
Does
You know,
source
there's
address
two ways to
selection
put it.
take advantage of the PVD ID?
Depends on whether or not you've got a PVD end system implementation.
I think what you said is probably true in principle, but if I were to do that, the thing would just stop working, and that would be the end of it. Right.
Well, you need something that understands how to read into the PVD,
right?
For sure.
But I can't assume
But then you could do it.
Yeah.
Like I said, it depends. I don't know what the true purpose of this ULA router is. I know.
Well, so I didn't want to
Okay,
go into that
I
many
think we're
details.
going to need to wrap this up.
Okay.
I'll take it up. Email me later. I'll email you offline.
Yeah, we'll talk.
Thanks a
And
lot,
let's-
Ted. Thank you. Apologies for butchering your name, but Gyofeng Kian, you're up. You
Yeah,
got 5 minutes.
this is okay. This is Chen Guofeng. You can call me Godfrey. I'm from Huawei. This document is cooperation with my colleague Zhou Tianran. So this document just talk about an issue that is the pass MTU detection in the multipass scenario. Okay, we can go to next page. Okay, from this page you can see when the left part you can see they have two paths from R1 to R4. Then from the upper layer you can see the pass MTU should be learned about 1400. Because of the hash mark algorithm inside the router are fixed, so the pass MTU detect packet will always go into one direction. But the service packet with a different port, different IP address, maybe will go through other direction. So if it goes through R1, R3, R4, and the packet size is larger than 1,300, it will be lost. So this is, I think, is a very important issue. So the idea is looks like the right part. We can do the duplication in each point of the network because inside the router we can know how many load balance paths inside of the downstream. So we can do the duplication at the R1, and then it can send two packets from R1, R2 to R4, and another one from R1, R3 to R4. At last, we can get the result about the 1,300 is the minimal pass MTU from R1 to R4. So we can record this inside the R1. So finally, the packet will be cut to less than 1,300. Okay, next page. Okay, this page just shows the procedure inside of the network. You can see R1 find the two paths here. It will copy to two downstream links. Then from R2, R3, we will do the same thing like this. At last, if the packet go to the arrived R4, it will reply to R1 each packet, each copy. And at last, R1 gets the response from R4. It can calculate which one is the minimum one. And at last, it will record in its memory for the following service packet to do the slicing. Okay. So right part just some consideration about how to modify the packet info, which I just consider to use the hop by hop extension header about the request direction, and use the DH extension header for the response direction. So inside of the packet, I consider to use the M tag and D tag to identify this packet is just for pass MTU detection, and D is identify the packet is due to the duplication. Okay, so at last we can find the whole procedure inside in this page. Okay, next one. So this page just show a consideration about the upper layer, which protocol could send this packet. Here, just an example, we consider use the TWAP light to trigger the pass MTU detection. So for the sender to know which one is which packets just reply for which one request one, we can use the sequence number to do the alignment. So at last, in the receiver, we can do the calculation according to the same sequence number. Okay, I think this is the whole consideration of the solution. This is the last page.
Okay, thank you. And we are out of time. So for these talks at the end, we don't have time for discussion. So please bring your comments to the list.
Okay, thank you.
Thank you. Okay, next talk.
Bob, can you help me find the slides for this one?
No, I can try.
Can we just let's jump ahead to the ND one so we can figure out the slides for this one. Paulo, do you want to go ahead? Thank you. Yes, apologies for not introducing this section, but this is the new work that is not been discussed on the list, allowing people 5 minutes to present new work. Please go ahead, Paulo.
Thank you. So Paolo Volpato, way I'm presenting on behalf of the people you see listed here. So next slide, please. So basically, let me just skip the details and the background of this work because I want to preserve times for the next speakers. But basically, we started from, let's say, an analysis targeting the first hope protocols. Then we moved to neighbor discovery after talking with a few operators. And the idea is to look at neighbor discovery, so 48, 61, and 62, to see if those standards leave room for solving the issues caused by prefix instability. Let me just say, as the chair was saying before, we have not received so many comments from the mailing list, so please feel free to comment or provide criticism to our work, so we are open to the discussion. Next slide, please. Again, very quickly, so there are options to solve the cases of prefix invalidity. For sure, for example, you can handle the timers defined in RFC 4861. So for example, you can decrease the timers to cope with, let's say, the valid lifetime. So the time a host maintains stale information, or you can modify or reduce the preferred lifetime, just to reduce the time for which a certain prefix is preferred. So this is a kind of operational process. It perfectly works. It's defined, if I recall it correctly, in 8978, maybe. It's a possibility. There is another option. So the option we choose is to look at the protocol behavior. So specifically 48, 61, and 62, and see if those protocols leave room to, let's say, solve the corner cases where invalidity applies. This is just explained in the next slide. So if you can do. Okay. Don't worry, it's a very complex slide, but I'm not going to discuss it at the moment. So feel free to have a look at the paper and you see the full explanation. But basically, you see on the left-hand side the solutions that we have identified to solve those corner cases where invalidity applies. And on the right, let's say, it's a list of proposals of modifications or changes to the existing protocols. So in a way that maybe just touching the basic behavior, we can also solve one of the corner cases that I've just highlighted where invalidity applies. Quick example, and then I move to the conclusion. Let's take one of the, let's say, updates introduced by version 02 of the draft, section 6.6. You see, we have thought of a synchronization flag, just to advise to let a router advise the hosts that the router advertisement is complete. So all the pieces of information needed for the configuration of a host have been signaled, have been passed on to the host. In doing that, in cases of misconfiguration, outage, abrupt reload, even if an array got lost before, if combined with techniques such as using non-volatile memory, the new array caused by maybe by a new prefix sent by the upstream provider is synchronized to the host. So the states are shared across the network. Sorry if I've been very fast, but I think
that's very good.
That's okay.
Thank you.
So comments? Welcome.
Thank you very much, Paulo. You beat your time by 1 minute, so it's extra bonus points. So Chen, now we found your presentation. So please go ahead.
Hello, everyone. Today I'm going to talk about a Multicast using Multicast routing head. Next page. Today I'm going to focus on the details will be presented in Pin's working group. Today I'm going to focus on the items in green. So introduction. The existing solution based on segment routing includes SR P2P policy and our previous draft, which received many comments from the Pin's working group. But this existing solution have some weakness. Multicast routing header is a good alternative for this existing solutions, which takes those comments into account and is more scalable. Next page. Multicast routing header is a routing header with new routing type. It contains subtree from next hop, SL, which is short for subtree left, points to the subtree from next hop. NB is the number of branches or links from next hop. B is used to indicate whether these are used for the links from next hop. For multicast package, ingress of a multicast tree will encap the package in multicast routing header for each of its next hop and send the package to the next hop. For example, here we have a multicast tree from ingress P1 to next hop P1. The multicast routing header will include the subtree from next hop P1 and the fields SL, NB, and B in the multicast routing header will be set to the corresponding value for the link from ingress node P1 to next hop P1. Next page. So this is the package received by P1. In the multicast routing header, the SL will point to the subtree from P1. There are 4 links from P1, which is P1 to P2, P3, P8, and P9. P1 will send a copy to each of these next hops. For the copy to be sent from P1 to next hop P2, the fields B, MB, and SL in the multicast routing header will be set to the corresponding values for the link from P1 to P2. For the copy to be sent from P1 to P8, P8 is a egress node. In this case, P1 just set SL to 0, and then the package will be sent to P8, which is in the bottom of the page. When egress P8 receives the package, the egress will decap the package and send the decapped package to the IP multicast for the module. So that's all. That's all. Any questions and comments? Welcome. Thank you.
Excellent. Thank you very
Thank
much.
you.
And this is work going on in the PIM working group, right?
Yes, yes. We'll go details in Ping working group.
Okay. Is it Shuping or Senbin who are presenting? Please go ahead.
Shuping, I think.
Hello, can you hear me?
We can hear you.
Good. This is Shuping, and I'm going to present the 2 drafts. Next, please. Okay, first, in APN, the APN information will be encapsulated in the outer tunnel header. And when the tunnel ends, the APN information will be removed. And with this information, it can be used for the fine granularity traffic steering or performance measurement. Next, please. The IPv6 extension headers such as a hop or DOH. And next, please. Okay, so here we would like to request for early allocation of the code points.
I think we've lost Chuping.
Yes, she was almost done. I think, regarding this one, we certainly have to be something we discuss on the list, and with our ADs also given APNs, having a few buffs. But yeah, this is something the chairs and the ADs can discuss, and we'll also take to the list, I think.
Yeah,
So,
and the early allocate. There's an RFC that describes how to do early allocations.
Okay.
So, Torles, I think you are next. Please come in the pink box.
Hello. Next slide. This is presenting on behalf of the two co-authors shown on the first slide. So this is another proposal for a native IPv6 solution for point-to-multipoint multicast services, stateless. So it's meant to extend the existing SRv6 architecture in terminology and functionality. The target solution group would be the PIM working group, as that has been, the group to outsource multi-point services from Spring, but that would be done through a new hop-by-hop extension header, which we typically do here, like we did SRH here. That's why I'm here. How do we compare? That was a high-level comparison here. So in SRH, the extension header carries a segment path, and we did start compression of that header 8 years after we introduced the original one, so very fast. And maybe we can do it even faster for multicast by starting with a compressed header, which is exactly what we think this proposal does the best from all the proposals out there. And the segment by segment forwarding would be exactly the same. On every segment, you're rewriting the destination address based on an extraction of the next segment from the extension header. So that's logically the same, but in the recursive bit string structure, we would obviously extract more than one address because we still want to do replication. That was the whole idea of multicast. And so then on the egress side, on the receivers, we probably would like to keep the same TLVs that we have in SRH. So that's another TBD item. So next slide. So here on the right-hand side, you see a distribution tree that is really encoded in the compressed addressing structure. So most simple thing, you're on the first router A on top. You have a set of bits, one each for each possible adjacency like next hop that you have. And then you've got the substructure for the subtree from that point on. So on every segment processing, what you need to do is on A, you need to basically take the red subtree, that's your new active address for the next hop toward B, and then for the copy toward C, it's the green substructure. So the question is a little bit, how do we do the rewrite? There are a couple of options. We could simply extract, rewrite, make it shorter. Not sure if 6-man would allow that. We can try to adjust a single segment offset, which would be exactly what the sequential one in unicast does. But if we actually have two offsets, maybe offset and length, we would be better compressed. So we're pretty open in how that could be done. So those, I think, are the options to discuss. Next slide. So then also, how do we split up the work, right? So the compression in Spring is now done by sticking within 128 bits. So it's kind of a strange split between 6-man and Spring. So can we kind of proactively, for this approach, figure out how to, split extensibility between 6-man and the subject matter working group like PIM? So that we bake in the extensibility upfront much better. yeah, and maybe even have multiple options, because seemingly, depending on what type of trees you want, there may be different compression options that we can have. So that's pretty high level. So if you're interested in the topic, next slide. Please come to PIM Thursday if you're interested in this. Otherwise, of course, all these questions I was raising against the 6-man specific things, I'd love to hear comments about those on the list, and I'll re-trigger that discussion here. Thank you.
Thanks a lot, Toles. And that brings us to the end of the session here in Vienna. And remote, feel free to send us feedback on how you thought the hybrid setup worked. I certainly noticed that there was a lot more activity in the room, I think, with questions and discussion than what we had remotely, even though it was 1/5 of the people here in the room, 4/5 remote. We don't know quite yet what we'll do for Philadelphia. Bob is out sailing to Hawaii. I'm out hiking to Mexico.
Or just to clarify a little bit, I will have hopefully arrived in Hawaii, and the question is, should I leave Hawaii and go to Philadelphia?
So we'll have a discussion with the ADs and the chairs for that. But thanks a lot, guys.
Yes.
Well, do it from the boat. Come on. That would be a first, right? Sharing from the boat.
Yeah, I cannot afford that kind of bandwidth. Well, thank you very much.
So is that shortening allowed? Well, say again? The extension head is shortening allowed. Yes, no, don't go beyond. I mean, I'm trying to figure out what's permitted by IETF. And it's easier to ask the expert than to.
So there are issues with changes to the package. So what I mean, what's empty?